Hi, this is Mrs. Damavandi. We're going to go over section 3.1 on functions today. So I want you to pause the video for a moment and look at this slide and answer one thing you notice or wonder about what you see. So hopefully you've noticed that in the ordered pairs, mapping diagram, on the table, and in the graph, these are all the same coordinate points. So like -3, 4, that's a point that's graphed. It's on the table because we have x as -3 and 4 as the y. It's on the mapping diagram because input represents x and output represents y. So these all show the same values. And maybe some of you know whether this is a function or not. A function is a special type of relationship between x and y, where each x value only is paired with a single y value. So if you look, for example, at the list of ordered pairs, there's a point 4, -1, and there's also a point 4, 3. So the x value or input value 4 has two y output values, which makes this not a function. And you can see in the graph on the right hand side, the 2 points that are vertical to each other on the same vertical line are those points 4, -1 and 4, +3. Last year you learned about the vertical line test. And if you can draw a vertical line through more than one point of a graph, whether it's a graph of like a solid line or just a graph of points, if you can draw a vertical line through more than one, it's not a function. We're going to go over all of that again. So, functions can be described in many ways. They can be described using equations. You can show a table of input and output values. Again, input means x and output means y. You can describe functions using words like story problems. You can show them on graphs, and you can write out a list of ordered pairs. So ordered pairs means coordinate points. So if I say ordered pairs, no, I'm talking about a coordinate point like 0, 8 at the bottom of the screen and 1, 6. Alright, so I'm going to play these videos. I'm not going to make them full screen because it's not working to make it small again without me stopping my video and stuff. So as best you can, try and see what's happening. Oops, go back. Alright, I want to play that. Alright, so this machine is supposed to be a function. If you see, I'm pressing the red cola button on the machine and it keeps giving me red. If I press the blue, it keeps giving me the blue cola. If I press the silver mist, it keeps giving me the silver one. If I press the green dew, it keeps on giving me the green cans. So functions are like machines is an analogy that's used because if you perform an input action, which is like pressing the button on a soda machine, there's one expected output. Like if I press on a regular soda machine that I want a Coca-Cola, the one thing it should give me out is a can of Coca-Cola. Okay? If we look at machine B, this one is not a function. So I'm going through pressing red cola a few times. It seems to work and give me the red one. I press the blue one a few times, gives me the blue. Pressing the silver one, that gave me green. Gave me green again. This time it gave me blue. This time it gave me silver. And then it gave me red. Okay? And then when you press the green, it works like expected and you see the green. So this one's not a function because of the silver mist button, that silver one. It has many different outputs that it gave as a possibility. So you don't know what could come out. It could be the red soda, it could be the blue one, but because it's not one output every time, it's not a function. Alright, so as I said, functions are kind of like a machine. Um, so if you get that input, you're supposed to perform some sort of operation, like the machines are performing the operation of actually finding the correct can of soda and spitting it out. Okay? A lot of functions are what's called one-to-one. So this is the idea of if you put in one thing, you always get out one expected thing. Okay? Like what happened with vending machine A. So this mapping diagram actually shows a function that's one-to-one because each x value on the left only is drawn and connected to one y value on the right. So it's called 1 going to 1. Okay? So what's not okay and what makes something not a function is if one thing goes to many. So that's what happened with vending machine B. The one button of Silver Mist went to many options of what soda would come out. Okay? What gets confusing though is many to one is allowed. So if we had, sometimes there's soda machines that have like two buttons for water or two buttons for Mountain Dew because those are really popular. Um, they're the same button or kind of button, and but it only gives out the one thing. Is kind of an analogy to go with that. So if you have many different starting inputs that go to one output, it's still classified as a function. Alright, here's an example to show you what many to one looks like. Okay? Oops, go back. I want to press play, not go to the next slide. Here we go. So we press the red cola button. Seems to be giving us red cola. Okay. Press the silver mist one. Seems to be giving us the silver can every time. So that's 1 to 1. If I press the diet blue, just because it doesn't give me the blue soda doesn't mean it's not a function. It's still just giving me one thing. It was that silver can. And then if I press the green it kept on giving me the green one. Okay? So it doesn't matter that the colors didn't match up. It just matters that it was still programmed to give me one thing. Press the blue button, it gives me the silver soda. So there was two different buttons, many, which went to one output of the silver can of soda. Okay? And that's still a function. So is this a relation of function? If we look at the x values, all of the x values on the table are different. Okay? So each x is unique, being a different value. You do see that 0 and 8 go together, and negative 10 and 8 go together, but it doesn't matter that the y values are the same, because this is a situation that it's many x values, input values, go to one y value, so it's fine, it's a function. If you actually take these values on the table, put them together, graph those ordered pairs, it would look like this. And if you remember me talking about the vertical line test, if you try and draw a vertical line through any of these points, it's just going to hit a single point. So it's a function. Okay? Here's another table. We have negative 2, 6, 0, 8, negative 2, 20. So I'm seeing an x value that repeats. Just because you see an x value that repeats doesn't mean it's automatically not a function. You have to check, is it going to the same value? Okay? So if it was negative 2 going to 6, and then on the table somewhere else it also had negative 2 going to 6, that's like how they try and trick you. when there's state test questions. So check your table. But since -2 is on the table twice and it maps to two different things, this is one input value of x that maps to many output value y's. So it's not a function. Okay? And if we graph it, we can see what something that's not a function looks like. Right here, this blue dot, which was our -220, and this orange dot, which is our -2 6, they are on that same vertical line. Even though I didn't get my vertical line through the points, they're on the same line. Okay? So it doesn't pass the vertical line test. It's not a function. Oh, I had it animated. Okay, so if we look at these options, which ones are functions, which ones are not functions? Okay, so the vertical line test is super useful if you have a graph. Let's get a different color. Let's get red. I like red. Oops. Okay, so not a function. Doesn't pass the vertical line test. Okay, B, this is a function. Even though it's a solid line that's made up of like points, like all of these are coordinate points, and we draw through them, it still passes the vertical line test because we're just going to go through this line once, no matter what vertical line we draw. So yes, this one is a function. In part C, yes, this one's a function. These points are all on their own vertical line. And then this one, in part D, this is a parabola that's laying on its side. Usually parabolas are U-shaped that go up and down, or like N-shaped that go the opposite of that. Okay, you'll graph these next year in secondary math 2. But we're just looking at it to see if it's a function or not. If it's going this way, look, we can go through the graph twice on one vertical line. So this is not a function. Okay, domain and range. You are going to need to understand what domain and range are. Domain is referring to all of the possible input x values of a function, and range is referring to all of the possible output y values of a function. Okay? If we look at A and B and talk about the domain and range, I'm going to write the coordinate points for all of these points in part A. So this one is -3, comma, -2. The next point is -1, comma, 0. This point is 1, comma, 2. And the last point is 3, comma, 4. All right, new color time. Orange. So the x values, these are always the first number listed in a coordinate point. These 4 numbers I've underlined, they are the domain. I'm just going to do D for domain. The domain is the numbers -3, -1, +1, and 3. If you were asked to list the domain, you would just list those 4 numbers. Let's get a little shot green. So now, y values. -2, 0, +2, and 4. If we were asked to list the range, we would just list these 4 y values. That would be telling someone what the range is. -2, 0, 2, and 4. Okay? So that's super easy when the graph is just coordinate points. If you look at part B, we see two endpoints on this little segment image that's drawn, but we have connected parts. There's all these little points that make up these connected line segments. So when you're looking at domain and range, you need to consider all of the possible x values, all of the possible y values. So I'm going to get some highlighting colors. If we look um, from left to right along the x-axis, we have one endpoint that starts here, and then we have coordinate points that go clear over, drawing the line up to here. Okay? Because if I put my pen somewhere in between here and like plot a point, there is a point right here that has an x that's a 1. There's a point right here that has an x that's 0. There's a point right here that has an x that's like -1/2. Okay? So over this shaded pink region, there are coordinate points that have those x values. Okay? This region is best described with an inequality, because inequalities are how we can list lots of values together. So all of our x values for the domain, they are less than or equal to 3, because 3 is our biggest possible x. But they're also greater than or equal to -2. Okay? If I start at -2 over here and keep going up until I get to 3, that is this inequality. So we are skipping over chapter 2, where we're going over inequalities, because I figured chapter 3 has a lot to do with graphing and linear equations that you learned a little bit about last year, and it would be a little easier for you to do while I'm not there. Okay? So do your best with writing these inequalities. If you need help, you can try and find Miss Passy, okay? Or email me, or ask maybe some of your 7th grade teachers that you know from last year, okay? But for this one, listing the domain, it would be this inequality. These are all of the x values. And then for range, do like yellow. For range, we're looking vertically, comparing where the function is drawn to the y-axis. So if I look down here, this is the lowest place that the function is drawn at -1 on the y-axis, and the highest it's drawn is up to here at 2 on the y-axis. So we need an inequality to talk about all of these values between -1 up until 2. Let's see, let's go yellow so it matches. So range, when we're talking about range, we need to use the variable y, because it's y values. I didn't say that when we were doing the inequality for domain, but when you're doing domain, you need to use the variable x, because we're talking about x values. Okay? So all of the y values are between -1 up until 2. So that means the y values are greater than or equal to -1, but those same y values are also less than or equal to +2. This is how we would show every possible y value over that section. Okay. So again, there's kind of an image. Domain goes from here to here. Range goes from here to here. So with these ones, we're going to find the domain and range. All right. So domain, R for range. Okay. We could even put domain x equals and then list all of the x values. So we have a point where the x is -3. We have a point where the x is -1. We have a point where the x is +1. And we have a fourth point where the x is +3. those are all of the x values that are graphed. And then range, our y values for those 4 points are 3 and +1 and -1 and -3. So it doesn't matter what order you list them in. You can list the numbers negative to positive, least to greatest, whatever, as long as you have all of the x and y values listed. All right, with part B, if we do domain, so domain goes from here up to here, because we're looking where is the graph drawn compared to the x-axis. So this is the furthest on the left that the graph is, and then over here is the furthest on the right that the graph is. Okay, so we're talking about x values with domain. The smallest x value is equal to -1, so we have all of the x values are either greater than or equal to -1 up until x is greater than, or x is less than or equal to, that is 3 right there. Okay, that's all the domain. Okay, and then with range, we're looking at where's the lowest that is drawn up until the highest point that is drawn. Okay, so compared to the y-axis, because we're going vertically, our smallest value that we equal is -3 up until equaling 2. So all of those y values are the y values where -3 is less than or equal to the y values, which are also less than or equal to +2. Okay, that's how you list all of the y values going from -3 up until equaling +2. So here's a list of things you need to connect in your brain. If you hear input, x values, domain, or independent variable, those all mean the same thing. If you hear output, y value, range, or dependent variable, those all mean the same thing. So I don't know if you have yet in science, but sometime you have learned about independent variable and dependent variable, or you will be. Independent variable is always your x value in math, and then dependent variable is always your y value. Okay? All right. So we're going to look at this story problem. And we're going to identify the independent and dependent variables. And then if the domain is 0, 1, 2, 3, and 4, what is the range? So we have a function, y equals -3x plus 12. So this is a linear function. You worked on graphing those when you went over Math 8 last year if you were in 7-8, or if you were in like Math 8 Honors or something. So it tells us that y represents an amount of juice measured in fluid ounces, and then x, oh, I read this wrong. Okay, so amount y in fluid ounces of juice remaining in a bottle after you take x gulps. So y is the remaining amount in the bottle, and then x is the number of gulps you've taken. Okay, so the independent variable, that is our x. Okay, so independent x value is number of gulps. So typically I like to explain that like the independent variable affects the dependent variable. So depending on how many gulps you've taken will affect how much juice is in the bottle. So that means y, which is the amount of juice. J-U-I-C. Juice in bottle. That is our dependent variable. Okay? So we are given some domain values and we're trying to figure out what the range is. So I'm just going to use our equation, y equals negative 3x plus 12, and I'm going to start a table to keep track of my domain and range values. Because it's just like if you just start plugging in the x values and figure out what the equation solves to, you figure out the y value. So our domain values for x are 0, 1, 2, 3, and 4. If we plug in 0, we're going to get 12. If we plug in a 1, we're going to get 9. Plug in a 2, we're going to get 6. Plug in a 3, we're going to get 3. Plug in a 4, we're going to get 0. Okay? So these y values I have on the table would be the range values.